Yeah. Yeah. Good evening, all. So myself, I'm Vijay. Like I hold 18 plus years of experience, which includes nearly 10 plus years of experience in Hadoop and Spark environment, right? So my experience in okay. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Can anyone please confirm whether my voice is clear, whether the screen is visible? Thank you.
Yes, sir.
Thank you. Right. So as part of today's demo, I'll be covering the following things. What is big data? Yes. Why Hadoop? Drawbacks with current databases. Drawbacks with current databases. What is big data? Why Hadoop? Drawbacks with the current databases. Hadoop advantages, right? Hadoop advantages. Yes. Hadoop job market. So Hadoop and I can say like Hadoop and PySpark. Hadoop and PySpark job market. So as part of this course, I'll be covering both Hadoop and PySpark. Fine. Observe this. What are the course content first? The Hadoop and PySpark is going to be covered, right? Yes. Big data Hadoop. Like what is big data? Why Hadoop? Need for Hadoop sources and types of big data. Comparison with other technologies. Challenges and advantages of Hadoop. Hadoop ecosystems. HDFS Hadoop distributed file system. And name node, data node, HDFS architecture, right? Metadata management, storaging, processing, replications, and fault tolerance in Hadoop and HDFS commands. MapReduce. MapReduce is a parallel execution model in Hadoop for processing. What are the various processing domains? Yes. And total MapReduce in brief. And Scoop for import or export operation. SQL plus Hadoop. The first two characters of SQL and last three characters of this form Scoop, right? Importing or exporting data. For importing data from database to Hadoop and even exporting data from this Hadoop to database. And while importing, we can perform many operations, importing, merging, performing joins, filtering, groupings, all this we can perform. Yarn, yet another resource negotiator, NoSQL database, and one NoSQL database like HBase is to be covered, right? And one of the important component of Hadoop, Hive. It's a kind of data warehouse kind of environment in the Hadoop framework. Total Hive in brief. So we'll be spending more time on Hive. Hive metastore, Hive query language, difference between HQL and SQL, loading data from local files, from HDFS, different types of tables, internal tables, external tables, working with unstructured data, working with XML data, working with JSON, working with URL and weblog data, Hive unions, Hive joins, and inserting into this HDFS files, UDF, user-defined functions, UDAF, UDTF, user-defined aggregated functions, user-defined tabular functions, partition tables, non-partition tables, um, partitioning, static partitioning, multi-column partitioning, dynamic partitioning, performance tuning mechanism, bucketing in Hive, indexing in Hive, and Hive and HBase integration. So total Hive in brief, it's a Hive is one of a processing components. It's a data warehouse kind of environment. We use a language called HQL similar to SQL as part of this Hadoop. And if I go to this PySpark, PySpark in brief. So PySpark introduction, right? What need for PySpark? PySpark features. PySpark sessions, PySpark context, parallelizing, repartitioning, broadcast variables, accumulators, PySpark RTD computations, RTD actions, inbuilt actions and transformations, steps in RTD computations, persistence, various persistence options, PySpark core computations, groupings and aggregations, single grouping, single aggregations, multi-grouping, multiple aggregations, group by key, reduce by key, various inbuilt transformations, various inbuilt actions. Okay, one by one inbuilt actions and transformations with some working examples. So like count by key, count by value, zip, union, distinct, inner, outer, all these are the various actions and transformations. And PySpark SQL data frames using, okay, data frame API will be saying, right? Difference between RTD and data frame, Spark creating data frame, RTD to data frame, difference. So struct type, row class, column class, select, collect with column, column renamed, and when various built-in types, all this, right, in brief. And SQL, PySpark SQL functions. You have got aggregated functions, window functions, date and timestamp functions, JSON functions, reading and writing, and various built-in functions of PySpark when expr, lit, split, substring, translate to timestamp, various date and time related. Yes, one by one, all this with some working examples. And PySpark external sources working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON, transformations actions, narrow and wide transformations, adding new columns, dropping columns, renaming, addition of new rows, dropping, handling nulls, window function, right? Deployment modes, local mode and cluster mode, PySpark applications, stages and tasks, driver and executor, deploying Spark applications, performance tuning, PySpark streaming, right? PySpark streaming concepts and the integrations with Kafka, integration with Kafka, right? One of the streaming component, and also PySpark ML machine learning library. And before going with PySpark, right? If you people who chooses this package, even with Python package, this is with Python package and without Python pack. Two packages are there for this course. With Python means again, this entire Python core and advanced will be covered because the total coding goes in Python, right? For PySpark. So entire Python, like Python basics, Python operations, operators, Python IDs, flow controls, looping statements, strings, collections, Python lists, Python tuples, Python sets, Python dictionaries, functions in Python in brief, modules in Python, packages, errors and exceptions, file handling, object-oriented programming concepts, regular expressions, extracting required data from the given data, database access connectivity, Python database, and the Python data in time, OS module, advanced concepts like iterators, generators, closures, and working with Excel files, data analytics, working with some introduction to data science, Python pandas model in brief, Python NumPy model in brief, Python matplotlib model plottings and visualizations, right? In brief, this entire thing, right? Yes. One second. So here, okay, one second. Here, first thing, Hadoop, PySpark, Linux, and Python. Okay, this entire package, right? It's the fee structure is 15,000 for it. So includes Python. You can attend Python classes any of my batch from Monday to Friday, a weekday batch. So it goes for 1.5 months, right? 45, 45 hours or 2 months, right? You can attend any of the batch. You will be getting, for all this, you will be getting the videos also, right? For every session video, you will be getting even Sometimes if you are attending, sometimes if you not attend the session, you may getting the video. You can go to the video and attend the next sessions. For Hadoop, PySpark, Linux, and Python, you will be getting the videos. Python nearly like 60, nearly like 60 sessions will be there on this Python. It will be from Monday to Friday. Whether you attend live sessions, that is, or you go to the videos of this Python, you'll be daily getting the videos of it. And these are weekend. This will be Hadoop PySpark Linux will be on weekend. This is on Saturday and Sunday. Saturday and Sunday. So now today and tomorrow, like for the first 2 weeks, it will be at 5 to starts at 5 p.m. Right? It will be like for 2 hours. And after this 2 weeks, like it will be like 4 p.m. to 6 p.m. on Saturday and Sunday every week. 4 p.m. to 6 p.m. it will be, yes. As of now, it will be at for the first 2 weeks, it starts at 5, but later it will be at 4 p.m., 4 to 6. So this Hadoop PySpark and this totally like 12 weekends it goes. It goes for 12 weekends. It's like 3 months in brief. These two courses, Hadoop PySpark and Linux also will be discussed. 12 weekends. And this Python separately, it will be in Monday to Friday, like any of my batch you can attend. There are many batches of my Python classes. Yes. And what is that Linux knowledge required for this understanding this HDFS, Hadoop, and this PySpark? That will be covered, right? Everything will be covered. Yes. And people who already knows Python, if it doesn't want Python, right? Just Hadoop and Linux. The fee structure is 12K for it. Okay. Yes. Okay, the general queries I'll be giving time for you at the end of the session. That is the course content. That is what I'm going to do. Right. Coming to this big data, even right, even if you see, just open this and check for this data engineering jobs. Like if you see like Hadoop jobs, you can say can try for Hadoop developer like Hadoop jobs. Just check in this Google, right? Hadoop jobs, right? 8,997 Hadoop job vacancies in January, right? And even if you go for like PySpark, so both they ask Hadoop and PySpark combinedly. PySpark jobs, PySpark developer, right? Python PySpark developer, right? So PySpark jobs, 19,190, 169 PySpark jobs, right? Or now, right? So many PySpark jobs. So PySpark has got great boom today. Very very far, very high speed processing technology, right? Even if we see the salary packages for PySpark, especially as compared with other technologies, 1.5 times more than the other technologies, right? So yes. So coming to this big data, right? The name itself saying like huge volumes of data, huge volumes. Today, if we see previously, if we go 20 years back, right? Should have seen the data storage was in KBs and MBs, right? KBs of data, MBs of slowly we went into GBs of data and terabytes. You should have seen KBs, MBs, GBs, or even TBs of data. But today, data is getting generated in petabytes and petabytes. If you see after petabytes, we have got exabytes, zettabyte, zottabytes, yottabytes, so on, right? So from TB, we say it's like huge data. 1 petabyte equal to 1024 TB. 1 petabyte equal to 1024 TB. Already 1 TB is a large storage unit. So, but petabytes of data is it getting generated in the current world? So, examples of petabytes of data generation. Examples of petabytes of data generation. We talk about the banking sector, right? If we take any bank like SBI, sorry, yeah, within the entire city, you see hundreds of branches for it. within the entire state, you see lakhs of branches, thousands of branches, and within the entire country, lakhs of branches for it. Again, in each branch, we see millions of customers, each customer making multiple transactions, right? So if you see the transactions per hour, per day, per week, per month, and a year, right? Huge data is getting generated. Apart from it, forget about this. Petabytes of data generation, the best example, right? You go like social media like Facebook, right? In a minute, what is the data generated by Facebook? How many posts and videos are getting circulated? Each and every post and video has to be stored, right? What should be the storage capacity to store all these posts and videos, right? Not only like Facebook, today there are many applications which are generating petabytes of data. Petabytes of data, right? Yes. Observe. If you take just 1 minute transaction, within 1 minute transaction, only like huge data. Yes. Like example, I said, in 1 minute, what is the data generated by Facebook? What is the data generated by Twitter tweets? Keeps on generating. And everyone querying in the Google, right? What is the data generated by Google, right? In a minute. And everyone creating your own videos and uploading in the YouTube. YouTube videos upload. What should be the storage capacity to store all the videos? And millions and trillions of people using email or Gmail messages. What should be the storage capacity to store all the messages? Just now I was talking about the bank transactions. Similarly for telecom transactions. Even for e-commerce websites like Flipkart, Amazon, right? Generating huge data. So here for all these applications are generating in petabytes. So we need to have some proper storage, not only storing the data, even processing the data as per the business requirements. So for storing in this, for processing this, we need to have some efficient tools, right? So currently we have got databases. Right? Yes. We have got databases like Oracle, MySQL, DB2, SQL Server. So these are used for online transactional processing, OLTP, online transactional processing for day-to-day operations. They can store data up to some extent in GBs of data, but there are some specialized databases. They have some specialized databases, right? Yes. If you're from database background, if you see the specialized databases like Teradata, Netija, Vertica. These databases, these are specialized databases used for data warehouse purposes, DWH. Data warehouse purposes. They're used for online OLAP, online analytical processing. Okay. So these specialized databases can handle data up to some extent, TBs of data, but to handle huge data in petabytes and beyond that for unlimited data storage, right? We doesn't have proper storage systems. So as a solution to all these storage and processing level problems, we have got a framework called Hadoop. So before I go, the services of Hadoop, what Hadoop provides. Before that, see if you see that data, the types of data, how this data is generated, the categories of data, right? Then the sources of data from where think this is the data generated from the last 50 years, from 1974 to 2024. Compare compare this last 10 years data. 1974 to 2014. Last previous 40 years data compared with last 10 years, 10 to 15 years, right? So in the total, whatever data you see in the current real world, 80% what we see is generated from the last 10 to 15 years. and only 20% of the data has been generated from the last previous 40 years, right? What is the reason to for huge data generation? What is the reason for this huge data generation, especially from the last 10 years? Reasons like usage of technology has increased, usage of smartphones has increased, usage of internet has increased a lot. Today, without internet, everyone carrying the internet, right? So usage of internet, smartphones, technology. So huge data is getting generated. And previously, if you see in 1990s, see the floppy disk where the size is 1.44 MB. You used to carry floppy disks, secondary storage devices like floppy disk 1 MB, 1.44 MB. Today, like we are carrying better GBs and TBs of data, right? What are the main sources from where this data is getting generated? Mainly, I can say like three sources of data. Mainly from social data which got generated from social websites, right? And data. If you go to any shopping malls, from the items you purchased, a very big bill is generated, right? The data which got generated by reading or scanning the barcodes, RFID chips, such kind of data we select machine data. And the transactional data, day-to-day transactions, telecom transactions, bank transactions. So mainly three sources, right, from where this data is getting generated. And this data, whatever is generated, the huge data is going mainly occupying the three types of data. Like you see like structured data, like Excel files, DB tables, database tables. Secondly, like semi-structured, you see like semi-structured data, which is not fully structured, which is not fully unstructured, like XML files, JSON files. And mainly today, if we see the data, huge data which is getting generated is mainly occupying this unstructured format, unstructured data. Like example, like your short messages, articles, images, videos, all this, right? Mostly unstructured data. So if you talk about this, databases can handle only structured data, which is in the form of rows and columns. But the biggest challenge is to store and to process this unstructured and semi-structured data. So Hadoop is a framework which can handle any varieties of data, like structured, semi-structured, and unstructured data. So as data is increasing enormously, right? We need to have proper storage systems, and not only storage, processing, right? So we have got a framework like Hadoop. Hadoop, it's meant for two things, for storage and for processing. It is meant for storage and is meant for processing. If you talk about any technology, right, it will meant for either storage or for processing. For example, C or C++ or Java or .NET, all this, they are meant for processing. If we talk about databases like Oracle, MySQL, DB2, all this, they are meant for storage. They are meant for what? Storage. Either they are meant for storage or meant for any technology. They are meant either for storage or for processing. But Hadoop, both storage and processing. Okay. You may ask, okay, for storage and processing, when Hadoop performs both, then what is the necessity of these technologies? When Hadoop, when performing both storage and processing, the two storing unlimited data and processing that unlimited data in quick time. What is the necessity? Means, yes, you need to understand Hadoop is for batch applications. Hadoop is for batch applications. For a single record, for example, one transaction has happened. For that, Hadoop is not required. See, Hadoop is bad for small data. It is good for huge data. For millions and trillions of records, go for Hadoop. So for storage, does Hadoop use any database internally? For storing the data, does Hadoop use any database internally? Means, no. Dra Databases has got some drawbacks. I'll just brief you about those drawbacks with the databases as compared with Hadoop. So despite of this despite of drawbacks with the databases, still Hadoop doesn't go with any database for storing its data. It is going with a kind of file system called HDFS, Hadoop Distributed File System, and for processing also, it is not using any technology like Java. And for processing, it is using MapReduce Spark. MapReduce and Spark. Okay. So both for storing and for processing, it is for storage HDFS and for processing MapReduce. So Hadoop, understood, right? Why Hadoop required? What are the Hadoop providing two services, storage and processing, right? Huge data. See here, if you take big data as a problem, huge data generation, then Hadoop will be the solution, right? Huge data generation, right? If you take, okay, if it is a problem, it's a solution. So Hadoop is meant for storing and processing. Now coming back, so what is the drawbacks with the current databases? Why databases are not used for storing this Hadoop's data? First thing, most of the databases limited storage in most of these databases you see in GBs or in TBs. Yes. And in most of the databases, no parallel processing, no parallel processing. And if volume increases in databases, if volume increases, speed decreases. If volume increases, speed decreases, right? For example, if you take any query, SQL query, select total amount, sum of amount from some aggregation, select total amount from sales one, select total amount from sales one. It has got 10 records. Assume it has got 10 records. Select average amount. Sorry. Sales 2. Sales 2 is one more table. It has got 1 lakh records. Select a total amount, right? Select a total amount or sum of amount, right? From sales 3. From sales 3. Three different tables, right? If we got 10 records, 1 lakh records, and 1 crore records, which query is going to execute faster? Among these three, yeah, select a sum of amount from sales one, select a sum of amount from sales two, sum of amount from sales three. Among these three, which query is going to execute faster, right? So this first query, obviously the first query, right? Obviously the first query, because total amount of 10 records compared with 1 lakh records or 1 crore, the first query. It means here query to query, as volume increasing, speed decreases. If complexity increases, speed decreases. Okay. Observe this, for example, select a sum of amount. Select sum of amount from sales one, right? From sales. So think that you got 1 lakh records. And if you are performing some different operation from the same table, average amount from, right, sales to, has got like 1 crore, right? Same sales one only, right? Sales one only, same, it has got same 1 lakh records. And third query, like select a standard deviation of amount from, right? Same sales one only. Yes, same, you got like, observe this. Yeah. Complexity increases means speed decreases. Total amount from sales fund, average amount from sales fund, standard deviation of which query executes faster among these three? The first query, right? Yes, the first query, because average amount is a two-step process. First sum to be calculated, next average to be calculated as compared to the first query. Second query takes time. And this third query, right? Lot of internal processing is required. Lot of internal processing is required. And databases, the major drawback with databases can handle only structured data. They cannot handle unstructured or semi-structured data. For example, right, databases handling only structured data. Observe. I've got a table. For example, if you want to take a reviews for a particular movie, reviews. The table name is reviews. User, they have got two columns. User is one column, right? A review. User one, user two. In this way, 100 rows are there. 100 users giving the feedback. If the movie is good, saying one. If the movie is bad, saying zero. Saying in the form of zeros and ones. Can you count the total number of ones and zeros by writing an SQL query here? Can you count the number of ones and zeros by writing an SQL query here? Single grouping and single aggregation. Single grouping and single aggregation, right? Select. Review wise. Select review wise count. Review wise count from reviews table, group by, select review wise count from reviews, group by review. Output. Review wise means 1 and 0 count. 90 people saying the movie good, 10 people saying the movie bad. Yes. So, okay, you can write an SQL query for this kind of structured data, but assume, so generally the users won't give review in the form of zeros and ones. They give in their own text format. First person saying movie is good. Second person saying movie is not good. Yeah, everyone saying, right, different. Now can you count? Now can you count? Can you write an SQL query to count the number of goods and not goods here? Can you write an SQL query to count the number of goods and not goods? If you use keyword count, go good, right? If you are using the keyword count, good. It gives wrong computation because even not good has got good within it. Yes. So to handle this kind of data, databases cannot handle this kind of data. Yes. So majorly like limited storage, no parallel processing. If volume increases, speed decreases. If complexity increases, speed decreases. Databases can handle only structured data. Hadoop advantages, right? Coming to this Hadoop advantages. Unlimited data storage. Unlimited data storage. Secondly, very high speed processing. Very high speed processing, right? Because of parallel processing, unlimited data storage can handle all varieties of data. Can handle all varieties. Can handle all varieties of data, right? Commodity hardware means it doesn't mean that Hadoop can run only on the highly configured systems. Commodity hardware, it can run on any hardware systems. No licensing for this, no licensing. Most of these Hadoop products are from Apache, right? If you go to Apache Mirrors, you can take that, you can download those and you can install it. No licensing, cost cutting, right? So mainly these three, right? Unlimited data storage, very high speed processing, can handle all varieties of data. Mm. So processing point of view, right? Processing point of view, right? So if we talk, Yahoo has taken, Yahoo has taken a table of 100 TB. Yahoo has taken a table of 100 TB consisting of 1024 columns. The task sorting based on 16 columns. Sorting based on 16 columns. So what is the time taken, right? Time taken by different databases. Time taken by different databases first. Oracle, it has taken nearly like 3.5 days to process it. MySQL has taken nearly 6 days to process. And it's a specialized databases like Teradata, as they can handle TBs of data, it has just taken 4.5 hours. Netija, another specialized database, has just taken 3 hours. Finally, Hadoop has taken 3.2, has taken just 3.2 minutes. Latest version of Hadoop has taken 1.4. So just see this in minutes of time, Hadoop is processing, where these databases are taken days. Specialized databases have taken hours. Hadoop has taken minutes of time. So Hadoop is proven in the market. Hadoop is proven in the market. Storage point of view, processing point of view. This is what processing point of view. That's why if you see today, most of these ETL kinds of project, ETL, right? Kinds of projects, they're migrating towards Hadoop and PySpark environment, right? Wherever you see like huge data like this, what I'm going to discuss, right? Hadoop ecosystem components. So, which has got both storage and processing. Here, like we have got HDFS, right? Hadoop distributed file system. Hadoop distributed file system. It is meant for storage. It is meant for storage, right? And we have got MapReduce. It's a parallel execution model meant for processing. It is for processing. It is for processing. And Hive. It's a mostly used component. Only on Hive we have got jobs. Lot of jobs on Hive. We got knowledge on Hive, right? So here it is also meant for processing. It is also meant for processing. Here we use a language called HQL, which is similar to SQL, right? Which is similar to SQL. HQL not only processing the structured data, it also processes this unstructured data, right? Yes. It's a kind of data warehouse kind of environment in Hadoop frame, DWH. Data warehouse kind of environment in Hadoop. Next, like Scoop. Scoop, right? SQL plus Hadoop. The first two characters of this SQL and last three characters of this, right? Forms Scoop. This is for import or export operations, not for storage or processing. It is for import or exporting data. HDFS initially doesn't have any data. Srinivas T, be in mute. Srinivas T. Import or export, right? Yes. Scoop, right? For importing or exporting operations. Scoop. From databases to HDFS, that is Hadoop environment, and exporting from Hadoop to databases, this Scoop, right? It works only for database and Hadoop only. This Scoop component is only for this. And NoSQL, I'll be discussing NoSQL, right? The NoSQL means not only SQL, right? Schemaless behavior. It has got schemaless behavior, right? If you talk about SQL, right? Structured means from first record to last record, same number of fields or columns has to be maintained. But in NoSQL, record to record, different number of fields can be maintained. First record with 3 fields, second record with 5 fields, third record with 7 fields, right? Yes. Schemaless behavior. And secondly, like random access. As part of this course, we have got many NoSQL databases: HBase, Cassandra, MongoDB, CouchDB, React, Peanut, Neo4j. Right? So HBase, it's a Hadoop database. It's a kind of NoSQL database, right? And Yarn, yet another resource negotiator. Whatever we are executing on this Yarn architecture, yet another resource negotiator, right? In the initial versions of Hadoop, there were some drawbacks. So all that from Hadoop 2 version onwards, everything got rectified. Yarn. And Zookeeper for controlling and coordinates all the Hadoop components. And I also provide knowledge on streaming, right? Streaming. Streaming data like Flume Kafka. Flume Kafka for streaming data, for live streaming data. Capturing live streaming data. Streaming data means data which keeps on generating. The data which keeps on generating. The data which keeps on incrementing. Such kind of data we call it as. Okay. So we also provide knowledge on this Flume and Kafka, that is streaming technologies, right? Yes. and mainly PySpark, Spark with Python implementation. So here we see like Spark core programming, Spark SQL, Spark streaming, Spark ML machine learning library, right? So PySpark. 50% of the time will be spent for this, more than 50% will be spent for this PySpark, and remaining 50% time for this Hadoop components. Nearly 60% I'll be spending of whatever duration, right? 60% of the duration will be spent on this PySpark, very high speed processing. Next, like 40 to 50% on this Hadoop, HDFS, Hive, Scoop, NoSQL databases, right? Yes. This is what will be discussed, right? Yes. And here I said Hadoop Hadoop is providing two services. Hadoop is meant for storage and secondly for processing. For storage, HDFS, Hadoop distributed file system. It is not using any databases despite of drawbacks. For processing, MapReduce, Spark. Hadoop is for batch applications. Hadoop is for batch applications. Batch applications, right? So there are two types of applications. There are two types of applications. Online applications. Hadoop is not for online applications, not for request response. Hadoop is not for request response. Online applications for batch applications. Online applications, Hadoop is not for online application. Whenever you give a request, giving response, not that kind of architecture. It's master slave architecture. Here user gives the input. On a user interactive applications, right? User interactive applications. Here user gives the input. User gives the input. Here example of this online application. Example of online application, booking a movie ticket. Compulsory user input is required. Making an online transaction. Transferring amount online. User input is required. Batch application, user non-interactive application. User non-interactive applications. Here user is nowhere required. Here user is nowhere required. Example of this, for example, railway ticketing PNR status, right? Currently your status is 200. After 2 hours it is 150. Tomorrow morning it is 90. Tomorrow evening it got confirmed. Here user is not doing, here is user involvement is nothing. User non-interactive, right? User is nowhere required. Example of this batch applications. Credit card, generating credit card statements. Generating credit card statements. for millions of customers. Millions of customers. Here, user is nowhere required in generating credit card statements or phone bill statements, right, for millions of customers. All these are most of these financial applications, banking applications, are batch applications without the user interference. Okay. User non-interactive applications, user is nowhere required. So drawbacks with the current databases, limited storage, no parallel processing. Okay, these things. Despite of these drawbacks, it is not using databases. So going with Hadoop distributed file system. Hadoop advantages, unlimited data storage, very high speed, can handle all varieties, commodity hardware, no licensing required. Yes. So this, it was just showing one example, right? The processing speed, right, as compared with other things, right? Very high speed. And this is what will be discussed as part of this, right? And this is the core structure. So in brief, like big data Hadoop, HDFS, map reduce in brief, scoop, yarn, NoSQL, HBase, Hive in brief, right? A lot of discussion on Hive, right? And PySpark, PySpark introduction, PySpark RTD computations, persistence options, PySpark core computing, groupings and aggregations, right? Various actions and transformations, PySpark SQL data frame, and PySpark SQL functions, PySpark built-in functions, one by each and everything. PySpark external sources, deployment modes, PySpark applications. And before we go with Python, right? Before you go with PySpark, you'll be given knowledge on this Python basics, operations, operators in Python, Python IDEs, flow control statements, looping statements, strings, collections, Python lists, tuples, sets, dictionaries, functions, modules, packages, errors and exceptions, file handling, object-oriented concepts, regular expressions, database connectivity, Python, datetime, OS, Excel workbook, data analytics, introduction to data science, pandas module, numpy module, and matplotlib in mod, right? Yes. So this just, it was introductory session, right? Introduction to Hadoop. Yes. So yes, tomorrow also you can attend the session, right? Today just it was introduction, right? Tomorrow just I'll also brief you about PySpark, the importance of PySpark. Yes. And also like storage point of view, how this compared with other things, why only Hadoop can perform unlimited data storage, why not the other things, why not the databases, other things, comparison with other things. All right. And also like introduction to this PySpark and how it is importance of PySpark. Yes. Any queries from your side? Tomorrow also same time at 5 o'clock, you can follow the same link to see more discussion on this. It will be continuation to what we have discussed. It's not like replication or not duplication of today's session, right? It will be continuation from, right? Tomorrow also you can attend, right? Yes. And if you see, I said with Python it is 15, without Python it is 12 here, right? Yes, you can see in the chart, there is a message given by this online team. There is a message given by this online team about the payment process procedures, right? Yes. Contact details, their contact details are given. Yes. So what are the offerings, right? Yes. So yes, you'll be getting the video, right? Session video. Every session video you will be getting, whether Python or Hadoop or PySpark or Linux, you'll be getting the session videos. Soft copy of the
Hello.
notes. One sec, please, just 1 second. I'll be giving time for your queries. Notes, right? Soft copy of the notes, classroom notes, and tasks to work with. And a WhatsApp group will be created, right? For technical discussions, right? Yes, WhatsApp group. And any queries from you? Yes, go with your queries now.
Sir, are you giving some intro on ETL kind of things
Pardon?
for ETL?
So yes, it's a kind of this mostly like ETL kinds of projects, right? We implement in Hadoop and Spark using this Hadoop and Spark. So
Only any
Previously like Informatica was very much used, right? Now Hadoop PySpark would mostly preferred for that.
Okay.
Okay, that we are using Scoop component. Data ingestion tools are there. How we are going to data ingestion tools like Scoop, Flume, Kafka, right? We are
Okay.
going to extract data from different sources and we are bringing the data to Hadoop HDFS, right? Storing in Hadoop HDFS. From there, any processing components like MapReduce, PySpark, Hive can take the data as input, process it. Again, they can store the data in HDFS. And from there, if you want to export it back to different other sources, like NoSQL databases or for normal SQL databases, right? You can import or export for those. Yeah. Okay. So don't worry about the software, right? I'll be providing the software to your Google Drives. To your Google Drives, I'll be forwarding the software. So I'll be demonstrating about the software, right? How to use, how to work on it, and how to work on different environments. I'll be showing you within this.
Sir, this soft copy material, will it be given daily or how do you give that?
Daily it will be provided.
Daily, right?
Whatever we discuss, everything will be practical oriented. Only for the
Yes.
first 2-3 sessions, right? We'll be discussing about the importance that what is Hadoop PySpark. But later, once we enter into practical, everything will be practical oriented. So yes.
Yeah. Thank you.
So here
Sir, can we do any PySpark project at the end of the course?
at the last, I'll be showing you right one. How the project
Okay.
flow I'll be discussing.
No, just for practice, like, can we do any real-time project, any small one?
I'll be just discussing the flow, but total thing, right? It takes a lot of time. The duration increases a lot. Yes.
Okay.
So already we are discussing for 3 months, right? 12 weekends, right? So that flow, everything I'll be discussing, right?
Okay.
Yeah. So tomorrow also you can attend the session to see more on this, right? Yes. Fine. So I'm stopping for now. If I'm done with your queries, meet you tomorrow, same time at 5 o'clock, the same link, right? Yes.
Hi, sir. Rishabh this side.
Yes.
Actually, I need to ask one thing. Actually, I'm working on the GCP thing, so I want to know means how the Hadoop is like useful in the into the GCP. Like there it is a cloud storage. So there were also the role in the Hadoop, or it's that totally different thing.
So Hadoop is for data engineering, right?
Yeah.
For data engineering. Uh, you bring the data, you pull the data from different sources, right? You'll
Mm-hmm.
it, and based on the business logic, whatever the business implementation, you
Mm-hmm.
just implement it, and the results on that results you are going to perform some kind of analysis. Later, by using this data scientist, they perform some analysis predictions based on that
Mm-hmm.
results you get. You apply different ML algorithms, right, on that.
Okay, so it is a means like it is a software which we have to be installed on the server, and
So
it's
So you know about this data. A typical data scientist currently
Mhm.
is dependent on this data engineering, the data engineer, right? For
Yeah, yeah.
exploring, for processing and getting the results. But
Mhm.
a typical data scientist need to have the knowledge about all this, right? Hadoop and
Mhm.
PySpark for pulling the
Okay.
data for processing it as per that business logic. Later performing some kind of analysis based on
Mhm.
this ML algorithms. Yes.
Okay, and one more question. What would be the percentage of theoretical and practical knowledge like that here in your session? What would be the like percentage like that? Are you working with the like some
So here,
theoretical?
1 second.
Mhm.
So there is this not a theoretical subject, right? It's totally practical. Whatever we discuss, everything will be
Mhm.
practicals. There is nothing theory at all. Don't expect any theory. So from
Mhm.
that first, you need to understand that architecture. The thing for the first initial 2-3 sessions, you'll be having some kind of how that architecture of Hadoop storage architecture, processing architecture, and how this storage is happening. Basically, you'll be learning. But thereafter, you won't see any theory. Everything will be practical. I'll be showing you practically.
Okay, okay, sounds good. Yeah. Thank you, sir.
And even I expect you people to just go to just do the practicals, not with anything, nothing theoretical. So just
Mhm.
to have a command on this subject, right? So even I was saying, right, especially for the Spice Park, it has got great boom today. So even the packages are big packages are given for the Spice Park developers, right? So
Yeah.
even when they are giving that huge unit, they will be expecting some kind of a command on these technicals, right? So
Mhm.
that you need to have that. So I'll be exploring all this with some working examples, right? So I want the sessions. That's what I was saying. I want the sessions to be interactive, right? Not me
Okay.
speaking and going off. So you'll be in unmuted status only. At any point from the start of to the session to the end of the session, you can ask any queries. You can interact.
Mhm.
Immediately you can ask the queries. Why like that? Why not like this? If you use this, anything you can ask. You can after the session you can experiment it. If you have got queries, you can interact in this WhatsApp group. You can the students, other students will be there. You can just debate on that, use for technical discussions. Even I'll be just responding for it. If anything in the next session, at the start of the session, you can ask. If you've got any queries, I'll be just briefing to all, right? Yes. So I want
That's
all
it.
the sessions, coming sessions, whatever we see. It's like even when I am going with the practical part, if I just
Mhm.
discuss one example on one data set, the other with other data set, I'll be just asking you to respond the steps, right? Yeah,
Okay, sir. Thank you. Sounds good.
yeah. So, okay, tomorrow, same time at 5 o'clock, use the same link, right? Tomorrow you can attend the session, but from next week onwards, next Saturday, the link will be changing. You are supposed to get enrolled. Tomorrow you can attend the session, but from next week, the link will be changing. You are supposed to get enrolled, right? By paying this fees, and you'll be given the link, and from next week onwards you'll be getting the videos to your Google Drives. Software you'll get to your Google Drive, and WhatsApp group you'll be added to the WhatsApp group, and notes you'll be getting to your mail IDs or WhatsApp group, right? Yes. Fine.
Sir, actually in this course, it was said that Hadoop, PySpark, Python, and Linux. So how Linux will be taught, sir?
So everything goes in Linux environment, right? So whatever knowledge required for Linux, that knowledge will be first, before I go with the practicals, first I'll be briefing you about this Linux, right? So people with
Okay.
zero knowledge on Linux, right? I'll be just briefing you. If you have got knowledge or if it doesn't have knowledge, right? I'll be briefing about the commands. Not the entire Linux is required, the basic Linux commands knowledge for understanding the HDFS commands, Linux commands are required. So everything we go with Linux environment, right? Yes.
Sir, what will the timing for the Python batch, sir?
So yes, 1 second. So you can see that contact details given in the, okay, 1 second. Let me share the screen. So there are some contact details given in that chart, right? You can interact about the queries related to this. So Python will be from Monday to Friday, right? Whether you attend the live classes or you can go through the videos of Python. If you got queries, you can ask. Monday to Friday, it goes for 1.5 to 2 months. Both Python core and advanced both will be discussed. So as of now, there is a batch at 6 a.m. in the morning, and there is a batch. See, now there is a batch going at 5 a.m., especially for the people from US, right? That's why in the morning 5 a.m. it is kept. For the first 1 week, okay, it will be for 1 week, it will be at 5 a.m. Later, it will be more to 6 a.m. 6 to 7, it will be. There is a batch from Monday you can attend, right, at 5 a.m. 1 week it will be at 5 a.m. Later, it will be at 6 a.m., right? That is in the people who go for morning. Evening, there is 7 p.m. That is also this Monday, 7 p.m., right? It will be for 1 week, it will be at 7 p.m. Later, it will be at 8 p.m. It's 8 p.m. to 9 p.m., right? The main batch timing in the morning, 6 to 7, and the evening, 8 to 9 p.m. Both on Mondays, this coming Monday, right? We had some introductory sessions previously, but actual technicals will be starting from Monday if you are either morning or evening, right? You can attend any of the session. You can talk to that online team, right, regarding this. So here also for first 1 week only it will be, later the timing 8 p.m. Here it's 6 a.m.
Sir, on the weekends, on Saturdays and Sundays, we'll be having Hadoop and PySpark classes.
Yeah, yes, Monday to Friday, these Python classes you can attend. Saturdays and Sundays,
Okay.
like 4 hours, Saturday 2 hours, Sunday 2 hours. Sometimes in the
Okay.
practicals, I'll be taking 2.5 hours, 3 hours also. But yes,
Okay. That what is the time set for weekends?
so weekends timing, I'm saying that. So it's starting at 5 p.m. right? This week and next week it will be at 5 p.m. Later 4 p.m. to 6 p.m. So I'm making clear about the timings, right? Again, before you do the payment. This week and next week it starts at 5 p.m. But after that 4 p.m. to 6 p.m. Saturday and Sunday. Okay, fine. Okay, any other queries, right? Yes. So you can ask the queries during the session. Through voice you can ask, or through in the chat panel you can type your queries. I'll be responding to it. Fine. Okay, so I'm signing off for now. Meet you tomorrow at same time 5 p.m. with the same link, right? Thank you all for your time. Thank you.